when we're working with radicals, we want to make sure that we simplify an answer. Simplifying never means getting decimals. Instead, we're going to use a factor tree to see if we can find any sets of numbers to take out of these roots. In the past, we worked with square roots. We simplified them by looking for pairs of numbers, because when we're working with a square root, there's that invisible 2 right there. When we're working with higher roots, for example, the third root or the fourth root, we'll simply be looking for sets of 3 or sets of 4 to get out instead of sets of 2. That little number, by the way, is called an index, if you want to refer to it as that. I think of it, though, as a warden, because I think of these problems as a prison break problems. We're going to try to bust as many numbers out of the prison, the radical, as we can, and to do that, we need a set of 3, in this case, in the first example, to overpower the warden and get out. So, for example, the first thing that I would try if I was simplifying the cube root of 135 is I would try to just do that on my calculator. I would type in the cube root of 135, and if you pause the video and try that, you're going to see that that is an irrational answer. The decimal goes on and on forever. It can't be written as a fraction. So we're going to know that we need to do this prison break thing. If you got an integer, though, then you could be done and just say it's done. So instead, we will need to use a factor tree to simplify this. So let's think of two numbers that multiply together to equal 135. I know 5 works because the number ends in 5, and then using a calculator, I can figure out that 27 is the factor that matches up with that. We keep factoring until we get down to prime numbers. This is the same thing we did when we worked with square roots to simplify them. 27 can be can be factored into 9 times 3. 3 is prime, but 9's not. That can be factored into 3 times 3. So we factored completely, and what's cool about numbers is that no matter how you factor it, they'd always end up the same way. So for example, 135, no matter what, would always end up a 3, a 3, a 3, and a 5. Although I think this is the only way we could have factored it. If a number has other options, they'd always end up with those the same factors for that number when you're done. So anyway, in this case, we're looking for a set of 3, and I can see that in my prime numbers, I've got a set of 3 right there. Any set that you have is going to be enough to overpower the warden and get out of jail. So out front, I'm going to have a single 3 because we have one set of 3s, and then I'm going to rewrite the jail. That's the cube root. Don't forget that index number. Some people forget that. And then anything that was single and left over would stay in jail. So that 5 did not get out. That's going to stay inside the radical. So my simplified answer is going to be 3 times the cube root of 5. And if I type that in my calculator, I'd see it's the same decimal I got originally if I had done that on the calculator. Okay, let's take a look at one more example just using a simple integer, and then in our next slide we'll take a look at what to do with variables in the problem as well. So in this case, my index is 4. I need to find a set of 4 if I want to bust out of this prison. So let's take 48 and break that down. There's various ways you can break down 48. I'm going to use 6 and 8. If you use something different, go ahead and continue it. You'll see that when we're done, we're going to get the same factors, as long as you guys factor correctly, of course. 6 breaks down to 3 times 2. 2's prime. It's the only even prime number. 8, I like 8 because I like to do this. Normally we just factor into 2 numbers, but I know that 8 is 2 times 2 times 2, so I just save myself a step and do that. You don't have to, but I like to save myself a little bit of trouble. So again, you may be factored differently, but you should have ended up with 4 2's and a single 3. So looking at all those prime numbers, I want to find any sets of 4 that I have. Well, right there is a set of 4 2, so I'm going to circle all those. The set gets to come out, and it's one set, so I'll put down a single 2. What was left over inside the radical was that single 3. That's not getting out of jail, so that's stuck inside. So my simplified answer is going to be 2 times the 4th root of 3. Let's go ahead and try a couple more complicated examples where we have variables as well as numbers that we want to try to simplify. Alright, so these look a little bit more scary, maybe a lot more scary than what we just did, but really they're the same thing. Let's see what's going on here. So the first thing that I'm going to do is I'm going to kind of ignore all the variable parts and just look at that number, and let's pretend it was just the 5th root of 4 and do what we did previously. If I break 4 into its factors, I get a 2 and a 2. Well, in this case, I need a set of 5 in order to get out of this prison, and I can see that there's no way that 4 is going to get out. I cannot get a set of 5. So in other words, when I go to write my answer, that 4 is in jail for life. It's not going anywhere. It's not getting out of that prison. Next up, let's take our first variable. We'll do one at a time. And in this case, we have a to the 8th. What I want you to do this first time is write out 8 a's. That's what a to the 8th power means. So I've got, 4, 5, 6, 7, 8 A's all in a row. In a moment, hopefully we'll be able to do this in our head because you'll see some of these get quite large. So there's 8 A's written out. I need a set of 5, and I have that. There's a set of 5 A's right there. They're going to be able to overpower the warden and get out of jail. So out front, I'm going to have a single A for the set of A's that escaped. Notice though that not all the A's got out. 3 of them were left behind. So inside the jail, I still have A to the 3rd power. Get what's going on? Next up, let's do the B's. Well, this time, I don't really want to write out 14 B's. If you want to, if it helps you, then go ahead and do it. But let's try to do this in our head. So imagine 14 B's all in a line. I want to see how many sets of 5 I can get out of that. Well, if you imagine 14 B's, you should be able to imagine 2 sets of them. So I'm going to put B squared out front. If you have trouble seeing that, then go ahead and write out 14 B's, and you can see that there are 2 sets of 5 that you can circle. However, there will be some left over. There's 4 of them that did not get paired up, so B to the 4th remains inside. And last up, let's go ahead and do the C's. I have 5 C's, so again, try to do it in your head, otherwise write out C, 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 C. I don't know if I said C enough times, so write out 5 C's. I need a set of 5, so of course there's 1 set that I can get out, so that would be a single C. And this time, they make a clean sweep. None of the C's got left behind. They all made it out of jail, so there is my simplified answer. If you think you got it, actually no, I take that back. I want to do one step first on this last example, then I'll have you guys pause it and try on your own. So in this last example, we have 2 things multiplied together. My advice is go ahead and multiply those together first. So let's make a single cube root problem. The numbers 4 and 12, the coefficients, behave like normal numbers like they always do. So just go ahead and multiply those together. We get a 48. And then if we continue, x to the 3rd is the only x term, or only x piece, so I'll include that. And then y to the 5th times y squared, we'll add our exponents together to get y to the 7th. So I would recommend you guys start with that and now do one massive prison break problem. I've talked through a bunch of them, so I want you guys to try this one on your own. Go ahead and pause the video and see if you can work this out. Otherwise, let it play through and my work will pop up real quick, and you can check your answer against mine. There's my answer, 2xy squared, and then times the cube root of 6y. Notice I had a 6 left over inside. This time I had a 2 and a 3 that were both single, so they would multiply back together and stay inside. The x's made a clean sweep. I was able to get 1 set of 3 out. The y's, I was able to get 2 sets out, but 1 of the y's was left over and it remained inside. Hopefully you got that answer. If not, ask me a question in class.